5G. The fifth-generation network, which is abbreviated as 5G, is the fifth-generation technology standard for broadband cellular networks in the field of communications, which cellular phone companies began to deploy worldwide in 2019, and as the planned successor, it has 4G networks that provide connectivity to most current mobile phones. 5G networks are expected to have more than 1.7 billion subscribers worldwide by 2025, according to the International Mobile Network Association. Like its predecessors, 5G networks are cellular networks, where the service area is divided into small geographic areas called cells. All 5G wireless devices in the cell are connected to the internet and the telephone network by radio waves through a local antenna in the cell. The main advantage of the new networks is that they operate with more bandwidth, giving faster download speeds, eventually reaching 10 gigabits per second (Gbps). Due to the increased bandwidth, it is expected that the networks will not serve mobile phones exclusively like existing cellular networks, but will also be used as a public internet service provider for laptops and desktop computers, competing with existing internet and telephone service providers. The new network will enable new applications in the Internet of Things, IoT, and machine-to-machine domains. 4G mobile phones cannot use the new networks, which require 5G support. The increased speed is achieved in part by using radio waves of a higher frequency than previous cellular networks. However, higher frequency radio waves have a shorter useful physical range, requiring smaller geographic cells. For broad service, 5G networks operate on up to 3 frequency bands, low, medium and high. The 5G network will consist of networks of up to 3 different cell types, each requiring specific antenna designs, each providing a different trade-off of download speed versus distance and service area. Mobile phones and technology-enabled wireless devices connect to the network through an antenna with the highest speed within range at their location. Low-band 5G uses a frequency range similar to 4G mobile phones, 600 to 850 MHz, giving download speeds slightly higher than 4G, around 30 to 215 bits/s. Low-band cell towers have a range and coverage area similar to 4G towers. The medium-band 5G network uses microwaves from 2.5 to 3.7 GHz, allowing for speeds of 100 to 900 bits/s, with each cell tower providing service up to several miles in a radius. This level of service is the most widespread, and should be available in most metropolitan areas in 2020. Some areas do not implement low band, making this the minimum level of service. High-band 5G uses frequencies from 25 to 39 GHz, near the bottom of the millimeter wave range, although higher frequencies may be used in the future. It often achieves download speeds in the gigabits per second range, which is comparable to cable internet. However, millimeter waves, mmWave or mmW, have a more limited range, requiring many small cells. The waves have trouble passing through some types of materials such as walls and windows. Because of their high cost, the plans aim to deploy these cells only in dense urban environments and crowded areas such as sports stadiums and conference centers. The speeds listed above are those achieved in actual tests in 2020, and speeds are expected to increase during commissioning. The industry consortium that sets 5G standards is the Third Generation Partnership Project, 3GPP. Any system that uses the 5th generation NR, new radio, software is defined as 5th generation, a definition that came into general use by late 2018. Minimum standards are set by the International Telecommunication Union, ITU. Previously, some reserved the term 5G for systems providing 20 gigabits per second download speeds as defined in the ITU IMD 2020 document. Overview. 5G networks are digital cellular networks, where the service area covered by the providers is divided into small geographic areas called cells. The analog signals that represent the sounds and images in the phone are digitized, converted by an analog to digital converter and transmitted as a stream of bits. All 5G wireless devices in the cell communicate by radio waves with a local antenna array and a low-power automatic transceiver in the cell, via frequency channels designated by the transceiver from a set of frequencies that are reused in other cells. Local antennas connect to the telephone network and the internet by high-bandwidth optical fiber or wireless connection. As in other cellular networks, a mobile device that goes from one cell to another is automatically handed over seamlessly to the new cell. The 5G network can support up to 1 million devices per square kilometer, while 4G can only support up to 100,000 devices per square kilometer. New 5G wireless devices also have 4G capability, as new networks use 4G to establish the connection to the cell initially, as well as in locations where 5G access is not available. Many network operators use millimeter waves for additional capacity, as well as increased productivity. Millimeter waves have a shorter range than microwaves, so cells are limited to a smaller size. Millimeter waves also have more trouble passing through the walls of a building. Millimeter wave antennas are smaller than the large antennas used in earlier cellular networks. Some are only a few inches, several centimeters, long. The massive MIMO, multiple input and output, 4G was deployed as early as 2016 and usually uses 32 to 128 small antennas per cell. At the right frequencies and configuration, it can increase performance 4 to 10 times. A stream of multiple bits of data is sent simultaneously. In a technique called beamforming, the base station's computer will constantly calculate the best path for radio waves to reach each radio device and organize multiple antennas to work together as phase arrays to create beams of millimeter waves to reach the device. Application areas. ITUR has identified 3 main application areas for the enhanced capabilities of 5G technology. These are enhanced mobile broadband, EMBB, ultra-reliable low-latency communications, URLLC, and massive device-type communications, MMTC. EMBB was only published in 2020, URLLC and MMTC are several years away in most locations. Enhanced mobile broadband, EMBB, uses 5G as an advance of 4G LTE mobile broadband services, with faster connections, higher throughput and greater capacity. This will benefit high-traffic areas such as stadiums, cities, and concert venues. Ultra-reliable low-latency communication, URLLC, refers to the use of a network for mission-critical applications that require robust, uninterrupted exchange of data. Massive machine-type communication, MMTC, will be used to connect to a large number of devices. 5G technology will connect some of the 50 billion devices connected to the Internet of Things. Most of them will use the less expensive Wi-Fi. The drones, sent via 4G or 5G, will aid in disaster recovery efforts and provide real-time data to emergency responders. Most cars will have 4G or 5G cellular connectivity for many services. Self-driving cars do not require 5G, as they must be able to operate where there is no network connection. While remote surgeries are performed over the 5G network, most remote surgeries will be performed in facilities with a fiber connection, usually faster and more reliable than any wireless connection. Before the 5th generation. A new generation of mobile phone appears approximately every 10 years since the first generation of the Nordic mobile phone system, which appeared in 1981. The first operation of the 2G system was introduced in 1992, and the first operation of the 3G system took place in 2001. Finally, a 4G system fully compatible with advanced IMD was in operation in 2012. Some government sources have indicated that a new generation of 5G standards will not be implemented by the ITU until 2020. Development of second generation, global system for mobile communications, and 5G standards, a third, IMD 2000 and UMTS, took almost 10 years from the official start of R&D projects, and the development of fourth-generation systems that began in 2001 or 2002. However, no global or international VSLN development GLOVDU for 5G VSLDH networks has been launched. Some industry representatives, they expressed their doubts about the 5th generation. New mobile generations frequency bands and the widest spectral bandwidth are usually assigned to each frequency channel, for example, 1G up to 30 kHz, 2G up to 200 kHz, 3G up to 5 MHz, 4G up to 40 MHz, but skeptics argue that there is still plenty of room for new frequency bands or bandwidth for larger 4G channels. From the user's point of view, this may imply that previous mobile generations had a significant increase in peak bit rate, i.e. the physical layer net bit rates for short-distance communications. However, no source indicates that peak download and upload rates for 5G will reach more than 1 gigabit per second that will be provided by defined systems. ITUR. The 4th generation. If 5G appears, and these speculations reflect, the main difference from a user's point of view from viewpoint between 4G and 5G technologies should be something other than increased maximum throughput, for example lower battery consumption, lower potential for interruption, better coverage, higher prices. Slightly in larger parts of the coverage area, cheaper or no traffic fees due to lower infrastructure deployment costs, or higher total capacity for many simultaneous users, i.e., higher system spectral efficiency level. Those are the goals in many research papers. An overview of the 5th generation in communications. The main slogan of the 5th generation is the Internet of Everything, or the so-called Internet of Things. That is, everyone and everything will be connected to the Internet, so any device or device at home, on the street or any workplace will be connected to the Internet, and this is what leads us to the term cities smart, as the data is formed everywhere by any person or any machine and will be analyzed in the least real time possible to infer useful information in a timely manner, such as monitoring the health status of patients and the elderly, monitoring devices and tools at home, and determining if there is a malfunction or a shortage of a substance, as well as analyzing the traffic situation on the streets, assisting drivers and warning them of unseen dangers, paving the way for self-driving cars. Here, mobile communications play a pivotal role in enabling the efficient and secure transfer of this information from one machine to another machine, equals machine to machine M2M, without human intervention, to process it and take the appropriate action with the maximum speed and the least delay, less than 1 millisecond. This poses more challenges on the future network, which must accommodate mobile phone data and the huge number of devices and sensors scattered everywhere to be a wide network with maximum capacity and efficiency and a high degree of security of devices transmitted and stored information.